Hey everyone, today we are going to solve the Daily LeetCode challenge of 18th March 2024 and the problem statement is minimum number of arrows to burst balloons. So let us first understand the problem statement. So according to the problem statement, we have been given a 2D integer vector points such that it contains both positive as well as negative integers, okay? And what does each of these vectors represent? Each of these vectors represent the points of a balloon on x coordinate, okay? Points on x coordinate, correct? Now what is this 2? This 2 is the start point on x coordinate and this 3 is the end point on x coordinate. Now what do I mean? I mean that let's say that this is a wall, okay, and we have a balloon over here, right? So this balloon will have some distance from the y coordinate as well as some distance from the x coordinate, right? This is the x coordinate and this is the y coordinate, but this y coordinate is not given to us, okay? Instead, what is given to us is this start and this end, correct? That is the start on the x coordinate and the end on the x coordinate, right? So what does this 2 represent? This 2 represent the start on x coordinate, correct? And what does this 3 represent? This 3 represent the end on x coordinate, right? So it means that let's say that we have a wall such that we have placed a balloon over there and we have been given the start of the balloon on x coordinate and the end of the balloon on x coordinate, right? And what do we want to find is, we want to find that what is the minimum number of arrows that is required to burst the balloon. Let's see that in this points array, we have been given how many coordinates? We have been given in total 4 intervals, right? So what does these 4 intervals means? These 4 intervals means that we have 4 balloons, right? So we have been given 4 balloons and we have to find that what is the minimum number of arrows that we want to shoot so as to burst all of these balloons, correct? Now, what is the condition to burst a balloon? We can burst a balloon if we shoot an arrow at a point x such that this x is greater than equal to the start coordinate on the x-axis and is lesser than equal to the end coordinate on the x-axis, correct? So let's say if I have been given a balloon such that it's in the interval 1 to 5. Now what does this 1, 5 means? 1, 5 means this 1 is the starting point of the balloon on the x coordinate and this 5 is the ending point of the balloon on the x coordinate, correct? Now I want to find that where should I shoot the balloon. So I can shoot the balloon at point 1, I can shoot the balloon on point 2 and I can shoot the balloon on point 3, on point 4 and on point 5. Why? Because you can see that this 1 is greater than equal to the start. What is the start? Start is 1. What is the end? End is 5. So this 1 is greater than equal to 1 and is lesser than equal to 5. True. Additionally, this 2 is also greater than equal to 1 and lesser than equal to 5. This 3 is also greater than equal to 1 and lesser than equal to 5. This 4 is also greater than equal to 1 and lesser than equal to 5 and same for this 5 as well. So whenever we have been given an interval, so we should choose a point in between them and we including those 2 points as well. And we can shoot the balloon at that point. And whenever we will be able to shoot the balloon in such a point x, then we can say that we have burst the balloon, okay? Additionally, it is mentioned in the question that if we shoot an arrow and if it has a balloon in between its path, then what it will do? It will shoot the balloon and it will continue to move forward, okay? And if it will have again one more balloon in its path, then it will again shoot that balloon and it will again continue to move forward. So it means that as much number of balloons would be in the path of the arrow, it will burst all of them, correct? And it will continue to travel on its path, right? So before discussing how we can solve this problem, let's first see that what all are the possible cases. So we can have 2 cases for this problem. So let's first discuss the case 1. Okay. So this is the 2D vector. So this is the 2D vector given to us in case 1. Let's represent this 2D vector over a number line. Okay. So let's represent the first interval. So the first interval is 1, 2. What does this 1, 2 represent? It represents that we have the first balloon over here, right? Let's represent the second balloon. The second balloon is from 3 to 4. So here is our second balloon. Let's represent the third balloon. The third balloon is from 5 to 6. So here is the third balloon. Now let's represent the fourth balloon. So the fourth balloon is from 7 to 8, correct? So here is our fourth balloon. So if we will see that what could be the possible point x such that this x is greater than equal to the start of x and it is less than equal to the end coordinate, right? So we need to find this x where we can shoot, right? Such that it's greater than equal to start and less than equal to end. So for the first balloon, what could be the possible values of x? The possible values of x could be 1 and 2. Similarly, for the second balloon, what could be the possible values of x? It could be 3 and 4. Similarly, for the third balloon, it would be 5 and 6. And for the fourth balloon, it would be 7 and 8. So what we can notice is that none of these balloons has any points in common. So what does it mean? It means that I'll have to shoot an arrow either at point 1 or at point 2 in order to burst the first balloon. And I'll have to shoot another arrow either at point 3 or at point 4 to shoot the second balloon. And again, I'll have to shoot another arrow either at point 5 or at point 6 to burst this balloon. And I'll have to shoot another arrow either at point 7 or at point 8 to burst the fourth balloon. So in total, how many arrows will we require? We will require 4 arrows. Correct. So what is the first case? First case is no overlapping. Correct. No overlapping. None of these balloons are having any points in common, right? They don't have any point x which is common to them. So because of that reason, we will have to shoot a separate arrow for each of them. Okay. So this would be our first case, non-overlapping. Now, how are we going to check whether these intervals, that is these position that we have been given for the balloons, are overlapping or not? So what we can do is, let's see, we can have a pointer over here that is at 1, 2. That would be our previous pointer. So let's say that our previous is 1, 2 and our current pointer would be at 3, 4. Fine. Now what do we want to check? In order for these two intervals to have something in common, or in order for these two intervals to be overlapping, what should be the case? The case should be that this 3 should be less than or equal to this 2. Then only they could have something in common, right? But this 3 is greater than 2, so they don't have anything in common, right? So what we will do, our previous pointer is over here, current pointer is over here. So whenever we'll see that they don't have anything in common, so what does it mean? It means that we need to shoot an arrow in order to burst that balloon. That is, we need to shoot different or separate arrows for each of them to shoot them, right? So let's say we will take a variable arrow. Initially, it would be 1. Now, what does this arrow represent? It represents that how many numbers of arrow do we require in order to burst all the balloons, correct? So at least we will require 1 arrow to burst the balloons, fine? Because you can see in the constraint that at least we will have 1 interval given in this points, okay? So what we can do is, since we have found out that these two intervals have nothing in common, so what does it mean? It means that we will require a separate arrow to burst this balloon, correct? To burst the current balloon. So what we will do, we will increment the arrow. So arrow will become 2. Now what we will do, our previous will get updated. So our previous will become 3, 4. Right, our previous will now point at 3, 4 and our current will point at 5, 6. So what we will have in current? We will have 5, 6. Now again, we can see that the start of the current interval is greater than the end of the previous interval, right? The start of the current interval is greater than the end of the previous interval. So what does it mean? It means that they don't have anything in common. So what does it mean? It means that we'll have to shoot a separate arrow to burst this current balloon, right? So what we will do, we'll simply increment the arrow. So the arrow count has now become 3. Fine. Now what we'll do, we will update the previous. So the previous will now point at 5, 6. So previous will point at 5, 6. And our current will point at 7, 8, right? So this is previous, this is current. So our current would be 7, 8. Now again, we can see that the start of the current balloon is greater than the end of the previous balloon, right? Where is the end of the previous balloon? The end of the previous balloon is here. And where is the start of the current balloon? The start of the current balloon is here. So the start of the current balloon is greater than the end of the previous balloon. So it means that they don't have anything in common. It means that they are not overlapping. So it means that for this current balloon, we will have to shoot another arrow to burst it, right? So what we will do is simply increment the arrow count to 4. Now again, our previous will get incremented and current will get incremented. So we can see that we don't have anything in current, right? So what does it mean? It means that we have completely processed all the elements that we have in this points, right? So it means that this is our answer. That is, we require in total 4 arrows to burst all these balloons, correct? So now that we have understood the first case, that is, the first case could be that none of the balloon are overlapping. That is, none of the balloon have any points in common such that we can shoot a balloon, and once that balloon got burst, the same arrow can burst the another balloon. So we don't have any cases like that, right? And how are we going to check for the non-overlapping case? We are going to check for the non-overlapping case when the start of the current is greater than the end of the previous, then we will say that they are not overlapping, right? Now that we have understood the first case, let's quickly understand the second case. So this is the 2D vector given to us in case 2. So let's represent these intervals over the number line, okay? So the first interval is 10 to 16. So it means that our first balloon is from 10 to 16. That is, here is our first balloon, okay? Now let's represent the second balloon. So the second balloon is from 2 to 8. So here is our second balloon, correct? From 2 to 8, right? Now let's represent the third balloon. So the third balloon is from 1 to 6. So we have 1, 2, 6. So here is our third balloon, correct? Now let's represent the fourth balloon. So the fourth balloon is from 7 to 12. So we have 7 over here and 12 over here. So here is our fourth balloon. Fine. Now what we can see is this interval and this interval are having some part in common. And which part is that? It's this part. Correct. So if we will shoot an arrow from the point 2 to point 6, that is, if we shoot an arrow between any of the point, that is, if we will shoot the arrow at 2 or at 3 or at 4 or at 5 or at 6, then what will happen? We will be able to burst the balloon which is in the coordinate 1 to 6, that is this one, and which is in the coordinate of 2 to 8, correct? So if we shoot an arrow in between or including this 2 and 6, if we'll shoot an arrow in this interval, that is from 2 to 6, then we'll be able to burst both these balloons, that is from 1 to 6 and 2 to 8, that is these two balloons will be able to burst, okay? So how many arrows we will require? We will require only one arrow to burst these two balloons, fine. Now we can also see that this one and this one is also having this part in common, correct? We can see that this part is common to both of them. So what does it mean? It means that if we will shoot a balloon from this 10 to 12, that is, if we will shoot at either point 10 or at 11 or at 12, then we will be able to burst two of the balloons. And which are those two balloons? The first one is from this 7 to 12. And which is the second balloon? It's from this 10 to 16. Correct? So how many arrow we will require to burst these two balloons? We will require only one arrow. So how many arrow in total we will require to burst all the four balloons? We will require this one plus this one. That is, we will require two arrows only. Correct? Now you might say that, but we can see one more overlapping. That is between this one and this one, right? This is an overlapping. So if we will shoot, let's say that if we will shoot an arrow over here between 7 to 8. So which two balloons we will be able to burst? We will be able to burst the balloon from this 7 to this 12. And the another one is from this 2 to 8, correct? From this 2 to 8. So how many arrow we required? We required one arrow to shoot these two balloons. But you'll notice that once we have burst this balloon and this balloon, we are left with this one and we are left with this one. And these two balloons have this one and this one have nothing in common. So it means that I'll have to shoot one for this one and one for this one. So for bursting this balloon and this balloon, I'll require two arrows. So in total, how many arrows we'll require? We'll require 3 arrows. But what have the question asked us? The question has asked us to find the minimum number of arrows, right? So which one we will prefer as the answer? That is, which one we will choose as the most optimal approach? The first one or the second one? Obviously the first one, because in the first one, we were requiring only 2 arrows, correct? Now, one more thing that I want to discuss is that which two balloons are we bursting first? We are bursting this balloon and this balloon, correct? These two balloons we are bursting first. So how do we know that what is the point X where should we shoot such that is greater than equal to the start and less than equal to the end, and it's able to burst both of these balloons at the same time? So we found out that this should be the interval, right? That is from this 2 to this 6. We should shoot an arrow from this 2 to this 6 in order to burst both of these balloons, right? And how we will get this 2 to 6? So we have the first balloon at 1, 6 and we have the second balloon at 2 to 8, right? And how are we getting this interval? That is where we should shoot. How are we getting that? We are getting that by finding the max of the start. So what would be the max of this 1, 2? Max of 1, 2. It would be 2. And we are finding the minimum of the end. So what would be the minimum of 6, 8? The minimum of 6, 8 would be 6. So what is the interval at which we want to shoot the arrow? We should shoot the arrow at 2, 6, right? So we should shoot from 2 to 6. So we can shoot at 2 or 3 or 4 or 5 or 6. So if we will shoot in between this interval, then only we'll be able to burst both the balloons. Similarly, if we will see over here, so we are using only one arrow to burst this balloon and this balloon, correct? Now, which interval should we shoot in order to burst both of these balloons? So what is the interval for the first balloon? The first balloon is from the 7 to 12. So we have 7 to 12, correct? And what is the interval for the second balloon? It's from 10 to 16. That is 10 to 16. And at which interval should we shoot? So let's find the start of the interval where we should shoot. So how we will find the start? We are going to find the start by finding the max of the start of this two. That is the max of 7 and 10. So what would be the max of 7 and 10? The max of 7 and 10 is 10. And how are we going to find the end? We will find the end by finding the minimum of this 12 and 16. So what would be the minimum of 12 and 16? It would be 12. So what is the interval? The interval would be 10 to 12. And here we can see that it's from 10 to 12. So either we can shoot an arrow at 10 or at 11 or at 12. And we will be able to burst both of these balloons. Correct? So now that we have understood that what would be the second case? The second case would be overlapping case. That is in which we are going to have some balloon which will be overlapping on one another, correct? So if they will overlap on one another, then we can use a single arrow in order to burst both of them, correct? And we also found out that how are we going to find the new interval. And what is the new interval? The new interval is the interval at which we want to shoot the arrow, correct? Because we want to know that at which interval we should shoot the arrow in order to burst all the balloons, correct? So we saw that for bursting these two balloons, it should be this. And for bursting these two balloons, it should be this, right? And how are we going to find that interval? We are going to find that interval by finding the max of the start of both of them and by finding the min of the end of both the intervals, correct? And now we have discussed the second case as well. So let's quickly do a dry run for this test case. Before that, let's quickly discuss our approach. What would be our approach? Our approach would be first to check whether the two intervals are overlapping or not. Now, if the two intervals are non-overlapping, then what does it mean? It means that we will have to shoot a separate arrow for the new interval, right? We'll have to shoot a separate arrow for the new balloon in order to burst it. So what we will do? We will simply increment arrows, okay? Otherwise, if we have found out that the two intervals are overlapping, then what does it mean? It means that they are having some points in common. So we can use a single arrow in order to burst both the balloons, correct? So what we will do, we will find out the interval where we can shoot the arrow, right? As we have seen in the previous case, right? We saw in the second case that if two balloons are having some points in common, say for example, this is the first balloon, this is the second balloon. So they are going to have these points in common. So what we are going to do is, if they are overlapping, we are going to find the interval where we should shoot the arrow in order to burst them. So if this is the first balloon and this is the second balloon, then which is the interval where we should shoot in order to burst both of them? It's this interval, right? If we will shoot an arrow in between this interval, then only we can burst this balloon as well as this balloon, right? So whenever we'll find that two intervals are overlapping, in that case, we are going to find the interval where we should shoot the arrow, correct? Now let's quickly do the dry run. So initially the arrow count would be 1. Now, why is this arrow count 1? So you can see in the constraint that here the length of this points would be at least 1, right? The length of this points would be at least 1. So what does it mean? It means that we are going to have at least one interval in the points. That is, at least we are going to have one balloon. So in order to burst one balloon, we will require one arrow, right? So initially we will take the arrow count as 1. Then we will take a previous pointer, which will be at this one. So we will have 1, 2 in previous, and our current would be 2, 3, right? So our current would be at 2, 3. So this is our current. Okay, I'm representing it with C. So what are we going to check? We are first going to check for non-overlapping balloons, right? So when we will say that these two balloons are non-overlapping, for these two balloons to be non-overlapping, what should we have? We should have previous end less than the current start, correct? Then only we are going to say that these two are non-overlapping, right? So we will see that what is the previous end? Previous end is 2, and what is current start? Current start is 2. So is this 2 less than this 2? So it's false, right? So what does it mean? It means that they are overlapping. So if they are overlapping, then what are we going to do? We are going to find the interval where we should shoot the arrow. So how are we going to find the interval where we should shoot the arrow? So the start of the interval where we should shoot the arrow would be the max of the start of previous, that is 1, and the start of current, that is 2. So what would be the max of 1 and 2? It would be 2. And what would be the end of the interval? The end of the interval would be the minimum of the end of previous and the end of current. So what is the end of previous? End of previous is 2 and the end of current is 3. So what would be their minimum? Their minimum would be 2. So which is the interval where we should shoot the arrow? We should shoot the arrow in the interval of 2, 2 in order to burst both these balloons. Additionally, if we represent them on number line, so we will have 1 over here, we will have 2 over here, we will have 3 over here. So where is our first balloon? Our first balloon is from 1 to 2. Correct? So this is our first balloon. And where is our second balloon? Our second balloon is from 2 to 3. This is our second balloon. So which point we have in common? We only have this point 2 in common, right? So we are having only this point 2 where we should shoot the arrow in order to burst both the balloons, correct? So we have found out the interval where we should shoot the arrow to burst both the balloons. Now, once we have found out the interval to shoot the balloon, what we will do? We will update previous, right? We will update previous because this is the new interval where we should shoot the arrow in order to burst both the balloons. So what would be our previous? Our previous would now become 2, 2. Okay. And after that, what we will do? We will increment our current. So our current will now point at 3, 4. So what we have? We have 3, 4 in the current. So now again, what we'll do? We'll check for non-overlapping case, right? So what is the non-overlapping case? We should have the previous end less than the current start. So what is the previous end? Previous end is 2. And what is current start? Current start is 3. So is this 2 less than 3? So it's true. So since it's true, what does it mean? It means that these two are not overlapping. So if we will represent these 2 points on number line, so what we will have? We will have 2 over here, we will have 3 over here, we will have 4 over here. Where is our this point? This point is over here, right? That is, we are shooting the first arrow over this point, that is at 2. And where is our balloon? Our balloon is from 3 to 4. So if we will shoot the arrow at this point 2, so we will be able to burst this balloon? No. So what does it mean? It means that these 2 intervals are not overlapping. So it means that I'll have to shoot a separate arrow in order to burst this balloon. Correct? So what we will do? We will increment arrows. So now our arrow will become 2. Okay. And now what will our previous will become? Our previous will get updated to 3, 4. So what we will have in previous? We will have 3, 4. Correct? And what would be our current? Our current would now point at 4, 5. So our current would be 4, 5. Right? So now again, let's check for the non-overlapping case. So what should we have? We should have the previous end less than the current start. So what is our previous end? Previous end is 4. And what is the current start? Current start is also 4. So is this 4 less than 4? So it's false. So what does it mean? It means that these 2 balloons are overlapping. So if these 2 balloons are overlapping, then what do we need to find? We need to find an interval where we should shoot the arrow to burst both of them. So what would be the interval and how are we going to find that interval? We are going to find the start of that interval by finding the max of the start of these 2. That is the max of 3, 4. So what is the max? The max is 4. And how are we going to find the end? We are going to find the end by finding the minimum of the end of both the intervals, that is 4, 5. So what would be the minimum? The minimum would be 4. So at which interval should we shoot the arrow in order to burst both these balloons? It should be from 4 to 4. Additionally, if we will represent these 2 balloons on number lines, so the first balloon is from 3 to 4. So here is our first balloon. And where is the second balloon? The second balloon is from 4 to 5. So here is our second balloon. So which is the common point? The common point is this only, right? That is 4. So if we'll shoot an arrow at this 4, then only we'll be able to burst them, right? So that's why this 4 is the common point. So what we will do now, again, we will update the previous. So the previous will now get updated to this new interval, that is 4, 4. And what would be our current? We will move the current pointer forward. So our current have now reached the end of the points. So what does it mean? It means that we don't have any more balloons left. So it means that we have completely processed all the balloons that were present in the points, and this is the answer. So what is our answer? Our answer is 2. And how are we getting this answer? We are getting this answer by firstly shooting an arrow at the point 2, 2 in order to burst these 2 balloons. So if we shoot an arrow at 2, 2, we are able to burst these 2 balloons. And the second arrow we are using to burst these 2 balloons. And where are we shooting that arrow? We are shooting that arrow at 4, 4. Correct? So it means that if we shoot an arrow at 2, we are able to burst these 2. If we shoot an arrow at 4, we are able to burst these 2. And our answer would be 2. Now I hope it's clear to you all. So let's quickly code this. Let us first create an integer variable arrows which would be initially 1. Now what does this arrow represent? It represents that what is the minimum number of arrow that we will require in order to burst all the balloons. And why I have taken it as 1? Because in the constraint it's clearly mentioned that we will have at least one balloon, right? So if we have at least one balloon, so we will require at least one arrow to burst it, right? So after that, what we need to take? We need to take a vector in previous of size 2. Correct? Previous of size 2. Let's take initially all the values as 0. Now, why are we taking this previous? We are taking this previous because we were supposed to maintain 2 pointers, right? First was previous and the second interval was the current. So what we will store in the first interval is in this previous of 0, what we will store? We will store the points 0, 0, correct? And what we will store in this previous one? We will store points, zeros, 1, correct? Now, what does it mean? It means that if we have this as the points, so what are we going to store in the previous? Our previous would be this 1, 2, right? So what we have stored? We have firstly stored in the previous 0, we are storing this 1, and in this previous 1, we are storing this 2, correct? But one more thing we should notice is that if we are given points like this, that is, it's in unsorted manner, right? So what we have to do is we have to sort them first, because only if we will sort them, then only we will able to check for these overlapping and non-overlapping cases by maintaining 2 pointers, right? So firstly, what we have to do? Firstly, we have to sort the array. So we will sort points dot begin, comma, points dot end. Right? After sorting, what we will do? We will create this previous, and after that, what we have to do? We have to iterate over this points, right? So what we will do? We'll write a for loop and we will start from index 1. Why? Because we have already used this index 0 in the previous, right? So our current will point from index 1. While this index is less than points dot size, what we have to do? We'll say that index plus plus. Now what we have to do? We have to first check for the non-overlapping case, right? And when are we going to say that two intervals are non-overlapping? We'll say that two intervals are non-overlapping when the previous end is less than the current start. Okay, so we'll say that they are non-overlapping. So first let's take current start. So we will say that current start is equal to points of index of 0, correct? And what would be current end? Current end would be points of index of 1, correct? So now what we have to check? We have to check for the non-overlapping case, non-overlapping, right? So when we will say that these two are non-overlapping, these two intervals means this previous interval and this current interval is non-overlapping. If the previous end is less than the current start, then we will say that these two are non-overlapping, correct? Let's take this over here. So we will have previous start as previous of 0 and we will have previous end as previous of 1, correct? So if this previous end is less than current start, it means that these two intervals, that is the previous interval and the current interval, are non-overlapping. So if they are non-overlapping, what we have to do? We have to simply increment the arrows. So what we will do? We will say that arrows plus plus, because if they are non-overlapping, then it means that we need an arrow to burst the current the balloon at the current interval, right? So that's why we have incremented the count of the arrows. And what we have to do? We have to update the previous with the current interval, right? Previous of 0 would be the current start. And what would be the previous of 1? The previous of 1 would be current end, correct? So we have updated the previous. Now after updating the previous, we are done with checking the non-overlapping case. Now, if we have that this current is less than equal to previous, then what does it mean? It means that these two intervals are overlapping. So if these two intervals are overlapping, then what we have to do? We have to find an interval where we should shoot the arrow, correct? And after finding that interval, what we have to do? We have to update the previous. So how are we going to update the previous? We will say that previous of 0 would be the maximum of the previous start and the current start, correct? And what would be the previous end? The previous end would be the minimum of the previous end and the current end, correct? So here what we have done, we have successfully updated the previous. Now what we have to do? Now we have to simply return our answer. So what is our answer? Our answer would be this arrows count. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the given 2D vector, that is, if we consider n as the size of these points, then the time complexity would be order of n. Why? So we can see over here that what we are doing inside this for loop. So we are simply iterating over all the intervals which is present in this points, correct? So if we have n intervals present in this point, so what we are doing? We are iterating over all the n intervals. So that's the reason why the time complexity is order of n. And what is the space complexity? The space complexity is order of 1 because you can clearly see that we are not using any extra space from our end, correct? So that's all about today's daily LeetCode challenge. Thank you.